Hello, everyone, and welcome to this Thorogood Associates webcast where we'll talk about how we can apply AI to innovate and migrate legacy data platforms to the cloud. First, allow me to introduce myself. I'm Ben White, a principal data and AI consultant with decades of experience in architecting, designing, and delivering enterprise data and AI solutions across a wide range of technology and clients. We're here today to talk about the migrations of systems and platforms to cloud-based environments and how we can leverage AI to ease the transition. We'll cover some of the considerations for a successful platform migration, how we can leverage new developments in AI to support the effort, talk about some of the key benefits in doing so, and end on how Thorogood can help. I'll also do a quick demo just to illustrate some of the concepts that we are covering in this webcast. Also, just to note, I'll be referring to a medallion architecture within your data lake of bronze, silver, and gold, which really refers to the different stages of data as it's transformed and made ready for consumption. This is parlance that has been made popular more recently, but could be anything really. It could be raw, semantic, cleansed, whatever best fit you and your organization, as long as it is logical and consistent. When we talk about migration efforts, you're usually talking about legacy solutions, which are often decades old, with lots of logic that has evolved over time and may have relied on expertise and knowledge that has departed the company. Approaches to platform migration over the years has certainly undergone a big transition from being a very labor-intensive undertaking in performing the discovery, analysis, planning, setting up the target environment, refactoring all the code, migrating historic data, doing deployments, testing, parallel runs, reconciliation, etc., then to a point where we introduced a lot more automation, things like infrastructure as code approaches to provision new cloud environments with just a click of a button, continuous integration, continuous development for seamless code integration and releases, automated testing and reconciliation, and much more. Now we're into the age of AI where we're seeing a lot more kind of semi-autonomous approaches to migration. So it's enabling companies to migrate large legacy estates into the cloud efficiently and reliably. These approaches are helping right from the planning stage through to the code refactoring, definition of test cases, taking quite a lot of the kind of manual heavy lifting out of our migration effort. However, many common AI-based approaches are performing like-for-like migration. So they're refactoring code to equivalent structures in the cloud technology, which, whilst it might put you onto a new cloud platform with all of the available features and AI services, is not necessarily and likely won't take advantage of all of the kind of features of the new platform and establish the kind of design patterns we are typically trying to establish in modern data platforms. For example, given the cost of storage, we're commonly looking to bring full fidelity of data from our operational systems into the bronze layer in the data lake that can be leveraged for all manner of downstream use cases. In the past, we might have taken particular decisions on the grain of data to store in our warehouse and brought in different cuts of data to serve different use cases, often going back to the operational system each time. The architectural patterns we are now establishing, whether it's bronze, silver, gold, or whatever nomenclature is being employed, will likely look quite different to the architecture that you might have had in your traditional data warehousing and reporting environment. The coding standards will likely be different. We might want to substitute stored procedures for notebooks and so on. So at Thorogood, we're taking a considered approach that leverages the power of AI where it makes to do so, recognizing the benefits, but also its limitations, and establishing a solid foundation that follows best practices you're looking to set up in your organization and build towards long-term success. So in thinking about establishing a future fit data platform as your migration target, there are a number of key considerations that we think that you should be consciously making. So the first is building out a platform in such a way that you keep your options open. So what I mean by that is not locking yourself into proprietary technologies and approaches that are then hard to untangle yourself from if you then need to move away in the future where essentially you're having to rebuild everything again. It has the advantage of maintaining incredible switching threat that can be used as commercial leverage, for example, with your cloud provider and commercial discussion. It means you're more easily able to avail yourself of any new capabilities wherever they are, which, as many people will know, are rapidly evolving at the moment. It also helps to avoid feeling like you're having to fit your approaches into the ways of the technology provider, and you can find the best fit solution for you. Closely linked to that is tapping into open source, so essentially programs, formats, libraries that are openly available. We found from kind of fairly early enterprise skepticism, open source is becoming a lot more widely embraced. It helps in preserving our optionalities. It's generally supported across different platforms and is interoperable across tools. It's also where we're seeing a lot of the innovation happening right now. The Spark is open source, the Llama family of LLMs is open source, LangChain is open source, and so on. And it has an incredible, thriving community element to it. And the innovation happening here is something that we want to be able to tap into. We should look to utilize frameworks, which forms the foundation of the migration approach we talk through in this webcast. In this context, we're talking about standardized code bases that are controlled by metadata. For example, an end-to-end data processing framework where we're telling it what to load using settings in a config file that informs it how to handle the data, particularly for doing pipelines that have a lot of similar functionality. This is an approach that we're putting into practice with our enterprise customers repeatedly to great effect. We've seen over the years in many customer environments, there might be a build-up of hundreds and often thousands of pipelines, which creates vast problems for you going forward. The frameworks offers you a clear strategy to talent and skill set development. You're not looking for a pipeline developer or an ETL specialist. You're looking for people who can understand the available tools and apply them in sensible and scalable ways across the technology options. And having a framework provides a single thing to manage, to optimize, and a single thing to innovate around. Finally, ensure proper data governance. This is much easier to do when you have consistent approaches enabled by framework, and that can then hook into your governance tools. So organizing and ensuring your data is discoverable means people can tap into it for their particular use cases and not try to reinvent something. Also ensuring data lineage is being tracked to offer confidence in your end-to-end data processing as you trace it through. And we should be thinking about all of this at design time and designing into the solution. It's often harder to re-engineer these things after the fact. But if you haven't designed it in from the start, don't worry, it's not too late. We are working with customers right now and applying these principles to ensure that they have ongoing efficiency and business responsiveness as solutions are being rolled out. So as I alluded to previously, we see end-to-end data processing frameworks as a key plank in your modern data platform. Not necessarily a new concept, but it's certainly more powerful and far easier to implement across different platforms than in traditional architectures. As mentioned, it's something that we're routinely implementing across our customer base, and it should form a key part of your target state. To explain what it is, it's essentially a single pipeline or discrete set of pipelines that control the load of your data through the various layers of your architecture based on metadata, which I'll illustrate here. So we have our data sources, which will feed into our target architecture. We will define metadata that stores details of the specifics of how to handle that source data. So for example, the source of the data, the format, the delimiter, primary key fields, and other details about the data so it can be pushed into Bronze using a set of generic functions. When I want to add a new data source, I'm simply adding metadata to a file, not creating new pipelines each time. We should be looking to store data in open formats such as Parquet and Delta and Iceberg to ensure interoperability with all of our reporting and AI tools and to ensure that we maintain optionality, as I previously mentioned. We want to ensure the right level of generic logic and specific logic where is required. But in this medallion architecture, we're typically landing the data into Bronze and pushing it through to Silver by adding metadata entry, which, as mentioned, are backed by reusable functions that allow us to land data, perform check, archive, log, create keys, maintain history, and so on. There might be some more specific transformations in the movement from Silver and then into Gold. This logic is defined as typically concise code blocks that purely carry out the transformations that are required and are then referenced in the load metadata. That the generic pipeline knows what to call when it gets to each step. And then that framework itself handles all the logging, DQ, lineage, and so on. So we don't need to define it in each different process. As mentioned, this is all orchestrated by a single pipeline in the main. So you only have one thing to maintain. You could add real-time streaming into our architecture. And we define DQ checks or data quality checks based on metadata as well. And these are checks that can be applied to any data set at any level of maturity through the platform. So Bronze, Silver, Gold. And these can be set up to check different scenarios that may indicate issues, things like null and duplicate primary key checks, schema checks, changes versus prior data points, missing periods, and so on, and is fully configurable through metadata. You should also look to establish automated testing, again configured through metadata, to ensure that we are matching back to the source and back to legacy systems in the case of parallel run, to provide assurances over the ongoing health of the platform. As mentioned, logging, lineage, monitoring, catalog should all be handled generically. It doesn't need to be built into every individual process or block of code. Having processed your data through the platform in a reliable and consistent way in open format, you then want to make sure it's well governed and available to your ML and AI tools and services for your advanced use cases. The framework that we lay out here is based on a framework that we have developed and implemented at many of our customers, which we think is a good framework and big, rich framework. However, the important point here is that you have a framework. There are a wide variety of benefits to putting one in place, which I hopefully came across in the last slide. But just to summarize some of those points quickly here, it's very quick to ingest a new data set. We're adding metadata entries, not building new pipelines each time. It's much more supportable. You're supporting a single framework, not hundreds or thousands of distinct pipelines. It ensures consistency in approach and in your standards, as you're using shared variables and shared functions, and the standards are not in the hands of each individual developer. It provides for a focal point for optimization. I can optimize one component of the framework, and every piece of data that goes through it will feel the benefit of that optimization. I can very easily add new components. So, for example, in a customer use case, we built a process to aggregate disparate data sets of a similar type into common data models that were consolidated to support a wide range of business use cases. And that was done in around 2 weeks. We can innovate on individual components as it's fully modularized to increase sophistication over time. For example, adding in anomaly detection into our data quality check. We preserve optionality through modular approaches so we can easily switch out components. It offers a clarity of vision to help organize teams around. And crucially, it scales technically. We're not throwing armies of people at the problem. We're designing intelligently for scale with parallelism. So with a framework in place, the legacy code and logic will need to be applied to that. And that's where we're really looking to leverage the power of AI to help us do that. We're taking in all of the existing asset into a large language model to produce the framework objects or the migrated code base. For example, we're connecting to our system tables directly to pull out the object definitions at scale and passing them to a large language model to unpack and convert to the coding language of the target architecture. We're using this approach to populate the metadata that powers the framework with details that can be derived from the source systems and execution flow to process the data. We're determining the dependencies that exist between objects to build out the dependency metadata that controls the flow parallelization of objects. We'll use it to refactor the code and table definitions to the target language of the target architecture with our defined standard. And finally, we can use it to generate and define test cases automatically to validate the outputs with consideration for the legacy and the migrated logic. A very important point to call out here is that we want to keep humans in the loop, and we're not just letting the machines decide here. So these approaches are still young and can be variable and have a limitation. So for example, in the context length, that can limit the output. So we should expect our developer teams to validate the generated outputs and combine them into our target solution. I wanted to now bring the approach to life with a bit of an example. So in this scenario, we have a relational database in Oracle with a wide range of materialized views, stored procedures, and packages that we're looking to migrate to Databricks in the form of functions and notebooks. Here we can connect to the Oracle instance via Databricks to read the system tables, pull out the definitions of the different objects, and pass it to an LLM to convert to Spark SQL and PySpark functions. These can be written out then in framework-ready Databricks notebook. There are obviously a number of complexities that need to be handled here in this scenario. So, for example, these are packages which can be extremely complex, multi-layered, and require recursive translation into the target logic. Into Informatica, in this case, is the enterprise ETL tool. which is slightly simpler to migrate as the metadata stored in tables describes the workflows, and we can use some reusable code assets and again, LLM to convert the logic to Spark SQL and PySpark code. Inherent within the existing logic in Oracle and Informatica will be some interconnected dependencies between objects, as different objects will reference one another. This is another area where we can utilize Gen AI to pull out the dependencies during the translation and populate the dependency files upon which our framework will run. So our framework calls for specific information about the objects contained within the solution, including details on how to read and generically process file-based feeds. So again, we'll adopt Gen AI to populate this metadata from the source data and the objects automatically. With that, we will have migrated all of the existing ingestion and transformation logic into the framework, and the table structures can simply be scripted out and translated to the language of the target object. So in this case, it's Spark SQL. Something we've not really touched on until now is the reporting and dashboard side of things. In our experience with large-scale reporting migrations, it's much more of a manual exercise. The Copilot approaches have emerged to, for example, capture the essence of reports and then recreate them in Power BI. However, in our experience, the manual effort to then take that output and apply the necessary standards and formatting is harder than just taking a standardized template and rebuilding the report. There are some areas, though, that Gen AI can be beneficial to adopt. In the case we have here, we can apply Gen AI to extract the XML measure definition from this case, IBM Cognos Framework Manager, and convert that to DAX measures, which would then use as a starting point for inclusion in our Power BI semantic model. The semantic models themselves are a pretty important consideration when we're changing technology. So we're typically trying to establish models that serve both reporting, dashboarding, and self-service needs. Whereas in some legacy systems, they might have been set up for one or the other, or not even be able to support self-service. So we expect specialist expertise to be applied to the design and migration of this area without the application of AI, but this is likely to be on a case-by-case consideration. There are a number of other kind of productivity, documentation, testing, and other aids where AI and Copilot will be adopted or can be adopted that I won't go into here. Once again, it's vital that we are keeping humans in the loop. We expect our developer teams to validate the Gen AI created outputs and adjust according to the appropriate standards and best practice. So I'll now jump into a demo to give a very quick illustration of some of the points that we're highlighting. Here I'll be using GitHub Copilot in VS Code by way of illustration. So here we are in VS Code. What I've done is connect to a folder with some SQL scripts. For the purposes of this demonstration, there is one script to ensure that it's efficient on time. So if I click on here, I can see this is my SQL script. It's a stored procedure that is just checking if there are any missing periods. So I can ask, I've got this chat interface on the right-hand side here, and I want to ask this to convert the SQL file to PySpark. Again, this is a folder which has one SQL script in it for the purposes of time, but you could imagine you can have a folder full of SQL scripts. You're asking the model here, in this case we're using Word model, to convert that script to the language of your choice. So as you can see here, it's going through, it's generated a .py file, which I can click on and see it has now taken that SQL script and converted it into a PySpark script that I can then use in my target solution. So I'm asking it to write some unit test cases to make sure that the result of the SQL and the PySpark script are the same, and to consider edge cases. The edge cases might be things where there are null values or blank rows, that kind of thing. I want to make sure that whatever data passes through, I'm going to get exactly the same result from my legacy script as my migrated script. So just give it a minute as it goes away and creates those scripts for me. See here, it's creating another .py file here, which giving a description of all of the test cases that it's generated that I can use testing purposes. So I can click on it here and I'll look through, and you can see it's created a number of different test cases that I can run to use in my validation. And these may form the basis of my ongoing validation to make sure as after my migration is complete, I'm doing a parallel run, checking back between the two systems to ensure everything is consistent going forwards. That was just a quick illustration of, some of the concepts that we're talking about here in terms of code translation and test script, and gives you a flavor of some of the areas where AI can be leveraged. I just wanted to touch on what a migration roadmap might look like at a very high level when taking some of the approaches laid out. So this is deliberately fairly simplistic, just to highlight some of the key points. Whilst we focus more on the execution of the migration in this webcast, AI can be applied to discovery and definition phase, so uncovering the asset, determining the complexity, the estimated effort, and so on. And there are a number of different tools across platforms that can help you in this discovery and definition phase. In the execution here, we present 3 core streams of activity. So we've got the gold layer migration UAT, building out the end-to-end ingestion framework, and enabling some of the additional features such as monitoring and data quality testing. The interesting thing here is that we're able to run them all in parallel. So in the first stream, we're ingesting the transformed or reporting data from your legacy system into the gold layer from the beginning. This migration should be relatively straightforward if you're mirroring the same structure in the gold layer. This allows you to start the migration of your front-end reporting system in the new environment earlier in the timeline and get your users testing the outputs. We typically find that in the legacy environment, logic may have evolved over time, and the result of that logic will be historically materialized into the final tables, meaning that if we were to just push all of our raw data through the existing logic, we would never be able to reconcile the full history. So therefore, it's necessary to really migrate the end state data into the new platform. Whilst that gold layer and reporting migration is taking place, we can leverage AI to build out the metadata in the way that we've explained for the bronze layer ingestion and silver to gold logic from our existing code base, and build that into the framework for the ongoing load and running of the system. The framework should enable automated testing, as we've discussed, to validate the results back to the legacy application. So it's important to really consider the length of parallel run between the new environment and the legacy one, with automated testing and reconciliation between these two systems running to ensure that there's no divergence between the solutions as time passes. Finally, the additional features such as monitoring and data quality features of the framework can be configured. So as we mentioned, the DQ checking mechanism is configured through Metadata, and it may be incremental functionality to your existing environment. So we may need to determine how failures are handled. So whether we're using holdover tables, we reject files, we issue warnings, whatever, as it may impact, how the outputs match across different systems if they're handled in different ways. Of course, there are many other aspects that we haven't covered here, such as security models, governance, support models, etc., that will also all need to be worked through. So just to summarize some of the key points that we have covered here as we come to the end of the webcast, that the advancements in AI are proving very beneficial in supporting the migration of vast legacy data environments in a number of ways, including code translation and test case definition, as I demonstrated. Start with automation approaches such as CI/CD, CT, and historic migration. It can greatly enhance the migration effort while offering a speed and reliability that was previously unavailable to it. When we consider a migration, we should be defining our target state architecture to be future fit and leverage frameworks where possible that have innumerable advantages going forwards in the management of our data estate and as we consider some of our advanced use cases. The approach is we scale the migration effort with technology as much as possible, not humans. However, we would always suggest that you keep humans in the loop to validate and verify any generated outputs and not simply rely on machines. And that's all we wanted to cover today on innovating and accelerating your migrations with AI. I do hope what I've taken you through today, you found it informative and helpful, and you can see how AI applied thoughtfully can benefit your migration effort. If you're interested in exploring the approach further with us, we'd be more than happy to discuss it with you. Just before we go, I wanted to share a little bit more about Thorogood for those who are new to us. So Thorogood is a global independent data and AI consultancy firm. Being a specialist in data and AI, we recognize what is required to deliver services of value to our customers, combining a strong business focus with data understanding and technology expertise. Our consulting services range from end-to-end data solution delivery and design, tool training, data strategy, roadmaps, and we operate across the spectrum of data and AI, from data visualization to data engineering, data science, and of course, AI. Many thanks for your time today. If you have any questions or want to get in touch, feel free to do so. My details are up here on the screen. But that's it for now. Please do check out our perspective page to see other videos and upcoming events. And we hope to see you at the next one.